Hello guys, welcome on Tesla Eduventures. In this video today we are going to discuss the basic difference between gas and vapor, and many times when I ask the students that what is the difference between the gas and vapor, so they answer me that the vapors in fact the gas of water is called as vapor. When we boil the water, vapor becomes, and this is also a correct definition, but there is a slight difference between gas and vapor, that gas cannot be liquefied by only increasing the pressure acting on it at constant temperature, which means that let us take an example of water, that if water vapor is above 374.1 degrees Celsius, which is the critical temperature of this water vapor, then this water vapor will not be the vapor now. It would be called as gas, and it could not be liquefied by only increasing the pressure on it at constant temperature. Which means that let us suppose that we have a cylinder which is in which there is a piston which is movable, and there is water vapor above 374.1 degrees Celsius. So at that temperature, let's suppose that that temperature is 375 degrees Celsius. So at 375 degrees Celsius, the water vapor in the chamber would be a gas, and if we maintain the temperature constant on 375 degrees Celsius, then by compressing that piston we could not liquefy the gas. In fact, gas would get compressed as much as you can apply the force on the piston, but it would not be liquefied. But if we decrease the temperature to 372 degrees Celsius, which is less than 374.1, then that water vapor would be in the vapor phase, and by keeping the temperature constant to 372 degrees Celsius, we can liquefy that that vapor back to liquid by compressing the piston more and more. So what is the basic difference between a gas and a vapor is the fact that gas cannot be liquefied into liquid by only applying the pressure at constant temperature, but the vapor can be liquefied directly by applying the pressure at constant temperature. So how to liquefy a gas? So to liquefy a gas, we must decrease the temperature of that gas beyond, in fact below the critical temperature, which is the boundary between the gas and vapor phase. So if we have to liquefy a gas, we should decrease its temperature below the critical temperature, and then we can liquefy that gas by only applying the pressure without changing its temperature. And that critical temperature for water vapor is 374.1 degree Celsius. Now let us discuss the saturated vapor pressure and humidity. So let us consider that we have three equal volume of container, and equal volume of water is poured into all three containers. The first container has some space and it is being sealed airtight with a lid. The second container has a lot of space and it is also being sealed with the hemispherical lid. And the third container is open to the atmosphere. Now what you will see eventually after some time, that the level of water will be highest in this container and will be lowest in this container. And this is a simple fact that due to evaporation, this water will evaporate to a large amount, because there is no restriction on this water to evaporate, and it would evaporate to the atmosphere. If we blow the air on this above this container, then due to the blowing of air, the molecules which evaporate are taken away by the air, and there is a pressure which is decreased in the region where air is blowing, and this could be understood by Bernoulli's principle, that if air blows with some greater velocity, then the pressure in that region is lower than the atmospheric pressure. So pressure in that region where air is blowing will be lower, and more space will be created to accommodate more number of molecules which are coming by evaporation from the liquid. So more liquid will evaporate, and the final liquid amount which would be left in the beaker would be very small. But in this case, the level of water would be the highest among three, because due to evaporation. Now you can see that the free space in this container is smaller as compared to the free space in this container. So in this container, initially evaporation will occur at a greater rate, but as you can see that the space available for water vapor is very less, so water vapor will saturate quickly in this container, and when the saturation will come, the condensation rate will be equal to the evaporation rate. So after saturation, any water which would evaporate after saturation will be directly condensed back into the liquid. But in this case, there is more space to accommodate the vapors, so more of the vapor will evaporate before coming to saturation, and after saturation point, any vapor that would evaporate after saturation will condense back into liquid. But obviously this hemispherical lid has a greater volume to accommodate more number of molecules of the liquid. So we can say that after the evaporation, saturation will come after a greater amount of time, after accommodating a large volume of vapor in the volume. So this is the saturation vapor and vapor pressure. And what is saturation vapor pressure? Actually, the vapor pressure applied by the saturated vapor is saturation vapor pressure. And saturated vapor, we have already discussed that the saturated vapor is the state in which any further evaporation will directly cause the condensation. Okay, so we would say that vapor has saturated. Now, what is humidity? We all call humidity in our day-to-day life, and we all discuss about humidity. But humidity is a technical term, and what we feel about humidity is the fact that when we say that today humidity is 40% or 60% or 92%, you must have observed that at the pitch report in a pre-match presentation in the cricket match, they also tells us about the details of the wind speed and humidity. So mostly when I was small, then I used to think that why they are telling the data of wind speed and humidity, and that data helps for a ball to swing. So you would be getting the videos on that fact also in fluids. But today, now in this video, we are going to discuss about the humidity. So there are two types of humidity, which are absolute humidity and relative humidity. So in absolute humidity is defined as the amount of water vapor present in air, and it is measurable in the unit of gram per meter cube. So it is just that amount of water vapor or density of water vapor present in air. Okay, and relative humidity is defined as the amount of water vapor present in a given volume of air at some temperature, and the amount of water vapor required to saturate the same volume of air at the same temperature. Or relative humidity can also be defined as the vapor pressure of air upon the saturation vapor pressure of air. Or we can say that if the humidity is 100%, then we can say that the amount of vapor present in the atmosphere on that day is sufficient to saturate the vapor in the atmosphere. So if relative humidity is 100% at any day, then the vapors are saturated in atmosphere, and any further evaporation by some water reservoir will directly cause the equal amount of condensation of that liquid, of that vapor back to the liquid. So on if we say that humidity is 50%, then it means that the vapors are only present in the amount which are half of the saturation vapors present in the atmosphere at any day. So this is the relative humidity. In the next video, I'll be bringing the details of the quasi-static process. Thank you.